Hello, everybody. Are you ready for our third talk of the day? I'm really excited about this talk. I was chatting to Dave there just between the talks, and he kind of admitted to me that I'm a product manager. I think I said that before, but in case some of you have come in new, as is Jan, and we were chatting to him, and he was saying, yes, he's in this incubator, they're building this cool tech, and then he says, I've got a confession to make. He says, we did do the techie engineering bit first, so we could ship fast, and then we had to think, okay, well, what is the customer wanting? Because you ship fast and you get it out, and then the customer's like, okay, so what? And then you need to start to think about, okay, how do you get product market fit? So we were chatting about product management techniques and some books to read, so that got us all excited. So he's going to talk through Chef's Kiss, a cookbook for product engineering with Gen AI. And I just realized I didn't actually introduce your name or who you are. But this is Dave Rant from GearSet. He's an engineering lead. So take it away.
Thank you very much. Hi, everybody. There's a lot of great talks happening today, so thank you very much for choosing this one. It's really kind of you. So today we'll be exploring how to create some of those chef's kiss moments in product engineering using generative AI. And this talk is a little bit of a confession as well. We did that thing where we chased Chinese a little bit. We learned a lot doing it, but this talk is a bit of a kind of lessons learned, and I thought it was useful to share it out with folks. So by the end, hopefully you'll have some actionable insights to make AI a core part of your product's value proposition. So there's lots of cooking puns. Let's get cooking. My name is David, and I've been an engineer at GearSet for nearly 4 years now, and an engineer in total for about 15. And GearSet is a company that delivers DevOps solutions for Salesforce engineering teams. This year, GearSet started on a journey to understand how we can help our customers succeed with Salesforce DevOps using AI. And I'm here to share some of the things we found particularly useful over that time. So AI is littered with buzzwords, so I thought it might be fun to keep an eye out for them as they crop up in this talk. So if you want to play along, there's a little bit of lingo bingo that we're going to do. Once you get the full grid, shout out bingo, and I have a couple of Lego sets down here that you can win at the end of the talk. I've got a little confession to make. I haven't rigorously checked when all of these words come up, so I'm going to have to just take a little bit of a leap of faith. So if you call bingo, I'll believe you. I'll just give everybody a second to scan them if they want. Great. So, AI has this huge potential. We're all fully aware of that, but it's not a silver bullet. And Gartner predicts that 30% of generative AI projects will be abandoned after proof of concept by 2025. 50% of finance AI deployments will either be delayed or cancelled by 2024, and 85% of AI projects will fail from poor understanding of AI's capabilities and requirements. So a poor understanding of AI's capabilities, a lack of data quality, and misaligned objectives seem to be the things that derail these projects. And this session is all about turning those odds around by trying to focus on real-world applications and rooting out value with AI solutions. So a couple of stories about kind of popular AI that we've seen over the past few years, and we can reflect on them as we go through the talk. In 2015, Amazon promised that Alexa would redefine personal assistance with vast compute power, state-of-the-art algorithms, and troves of user data. They had all the ingredients they needed. Yet, by 2022, Alexa was Amazon's biggest money loser. It cost them $10 billion. Why was that? Well, they had an undefined value proposition. It offered a wide range of tasks, but a lot of them lacked tangible user value beyond novelty and limiting engagement. They had a limited revenue model. Voice-based shopping and third-party app skills didn't really generate the revenue they needed. And there was a bit of market misjudgment as well. So consumers favored other interfaces like apps for complex tasks, and they ended up using Alexa primarily for basic functions like timers or playing music. And this is a reminder that even powerful AI needs to align with user needs and deliver measurable value to justify its costs. And if we go back to 2019, Google Duplex for web was pretty impressive. You could book reservations, purchase movie tickets, and it would automate all of these online tasks for you. But by 2022, it was quietly shut down. And why was that? Well, it tackled niche and infrequent tasks like filling out online reservation forms, which didn't really resonate with that many users. It had scalability issues, so it depended on constantly changing third-party websites, which made it operationally challenging to maintain. And again, there was a lack of a monetization strategy, and without that clear revenue model, it became financially unsustainable. And this is a reminder that AI needs to solve frequent, high-value problems to achieve that staying power. So, now I've convinced you all that you shouldn't bother with AI whatsoever. I've got to try and dig us back out of this hole. Let's see if we can turn things round. So Andy Ratcliffe describes this thing called product market fit as being in a good market with a product that satisfies that market. And he says, actually, for startups, that's the only thing that matters. And it's doubly true with AI. It's not what about AI can do, but it's what your users need it to do. You can feel when product market fit isn't happening because customers aren't getting real value from your product. Deals can be slow to close or they can fall apart entirely, but you can feel when you definitely have product market fit. Customers are buying faster than you can supply and the demand for your product kind of feels insatiable. So how do we ensure that AI products achieve product market fit with our users? So we're going to take a look at some product and engineering techniques that we can try and use to hit that product market fit. We'll start by exploring the potential of generative AI and how we can describe problems through the lens of AI's capabilities. Next, we'll look at some common techniques you might need to employ when working with generative AI. Then we'll look at how you can leverage AI to bring customers to your product. AI alone isn't a differentiator, so we'll look at techniques to apply it thoughtfully to our domains. And then lastly, we'll review some of the most popular product gaps that AI is being used to address in the market. So, the potential of generative AI. Over the past year, Gearset has been taking some time to consider how AI can drive value in Salesforce DevOps for our customers. And I wanted to talk about one of the concepts that we found most useful when considering AI in our product, and it's called the AI survival curve. And this framework has helped us evaluate whether an AI product has what it takes to thrive or fail by analyzing two key dimensions, consideration and context. On the y-axis, we have consideration, how much effort users need to put into making a decision. So choosing a detergent is a low consideration decision, whereas buying a car requires a lot of thought because it's high stakes. And on the x-axis, we've got context, and that's the amount of abstract knowledge that the AI needs to deliver that value to our user. So a model that only needs a small defined data set, that's got low context. However, something like ChatGPT, which is trained on the entirety of the internet, is high context. And this AI survival curve tells us whether an AI-based solution stands to solve the needs of our users. AI products that achieve product market fit do so by focusing on high return on investment use cases that ensure the cost of this context doesn't increase beyond the point of what's shippable to our users. And this sets us up to start a virtuous cycle of data collection if we can ship to our users and expand our product further as the technology evolves. So let's have a look at some existing solutions out there on the market and see where they land on the curve. We'll start with a low consideration, low context scenario, assistant skills like Amazon Alexa. And this falls below the curve because most of the use cases are low stakes, checking the weather, changing the volume, and they're low context as well, in that with Alexa's skills, it might be able to order you a specific item from a specific retailer, but it can't research that choice for you and then find it from the cheapest retailer available. Next up, if we look at a high consideration, low context solution, Stitch Fix are an online fashion company, and they have AI models that kind of augment humans to help you find your perfect outfit. So you get kind of a personal advisor as part of their service. And they use AI to help come up with outfits and products to sell you. This requires a lot of thought, and actually they still use human in the loop with their AI. But the options are limited to the stock that Stitch Fix maintains, so it's low context. If we then look at something that is moderate consideration and moderate context, we have a tool like Grammarly. And their AI is a writing assistant that has moderate stakes because it can help a huge number of people, and it has a moderate context as well because it needs to be trained on proper grammar, but it doesn't need to be trained on every piece of content ever published. And then if we look at a low consideration, high context scenario, we have something like MyFitnessPal, who have used AI for a feature in their app, which is called Meal Scan. And it tells folks how many calories they're consuming by simply taking a photo of what's on their plate. Accordingly, it's a high context feature. It needs a lot of data to be able to do that. But it's low stakes because the consequences are fairly minimal for it being wrong. And lastly, up in the top right-hand corner, we've got a high consideration, high context value, fully autonomous self-driving vehicles. And this is way above the curve because it requires a huge amount of training, and it's high stakes because we need it to be right 100% of the time. As the capabilities of AI progress, the survival curve is going to shift outwards towards those high context, high consideration scenarios. And the applications we think of today as mind-blowing, in 5 years, they'll be fairly commonplace. This shift will take time, but companies that embrace AI early will be prepared for the use cases that come down the road as the technology matures. And in 2025, I think one of the major drivers of this shift right will be the move to agentic AI. So large language models are a great starting point for experimentation, but compared to small language models, they're slow and they're expensive. The way that agentic AI can help you achieve your goals is by using a large language model in parallel with small language models. The large language model is responsible for being handed your goal, what you want to achieve. It can then delegate subtasks to highly specialized small language models that are likely to be able to meet those tasks with a higher quality bar. However, it's not all easygoing. We need to understand AI's limitations so we can overcome them with some engineering techniques. And we're going to look into that next. So, the foundation of any AI system is data. Garbage in, garbage out. AI's Achilles heel is truth, in that it doesn't know what is true. And the next big leap in earning users' trust is with complex, high-stakes problems. And the only way to earn that level of trust is through training. Reaching that point requires humans to continually teach AI what good looks like, and for that we need reinforcement learning with human feedback involved. I'm not going to deep dive into training or data pipeline techniques today, but here are some of the lessons over the past year that we found useful when it comes to using data and curating it to improve our model outputs. So, first up is that data quality is critical for success, and poor quality data often leads to poor model performance, and it undermines the trust and usability of your models. Next up is that data engineering is challenging. 70% of high-performing AI organizations, according to McKinsey, report difficulties with data engineering. And these challenges include governance processes, being able to integrate data quickly, and ensuring that sufficient training data is available for their models. Third up, you don't need every bit of data to train your model. And the guys at Hugging Face found that the use of clean and well-curated data sets can actually give you significantly better performance with generative AI systems. In fact, a data set that they put together, FineWebEdu, requires 10 times fewer tokens to achieve the same model performance than other open data sets. Domain-specific data yields better results. It outperforms generic data for AI training because models align closely with the specific business or user needs. And lastly, synthetic data has its limitations. So you can use synthetic data to augment your data sets, but if you have too much reliance on it, it can end up diminishing your model quality. Access to diverse human-generated data is still hugely important. And with too much synthetic data, you end up in this scenario of what's called model collapse. So, next we'll look at some of the concepts we found helpful when prototyping and experimenting with AI, particularly optimizing models for the task at hand. Optimization with generative AI is hard. It consistently boils down to 3 reasons. The first is not knowing how to start optimizing. The second is when to use which optimization method, and the third is what level of accuracy is good enough. Many how-to guides on optimization paint it as a really simple linear flow. So you start with prompt engineering, then you move on to a technique called retrieval augmented generation, and then fine-tuning. However, it's not really the case, and these are all tools that solve different problems, so let's explore them for a little bit. Prompt engineering on the left is a great place to start. It's often the only method that you need for use cases like summarization, translation, and code generation to achieve good results, where a zero-shot approach can hit the kind of required levels of accuracy that you need. There's a lot of material out there on prompt optimization, so I'm not going to go into it too much, but things you may need to do with prompt engineering are things like providing reference texts, or using external tools, or splitting complex tasks into subtasks. However, the biggest issue with prompt engineering is that it often doesn't scale, and either we need to be able to retrieve dynamic information based on the task that we're asking the model to do, and we can't stuff enough information within the context window for that model, or we need more consistent behavior and outcomes that we can't achieve with some few-shot examples supplied through prompt engineering. So, once you've finished your prompt engineering, a good prompt and a set of evaluation questions and answers is a really good output from that stage, and you can then use that to take on more advanced optimization. The first option we have for introducing specific additional knowledge to our models is RAG, Retrieval Augmented Generation, which is where we go and find specific information based on the task at hand, and then we reintroduce that into our model to try and increase the accuracy of the outputs. However, RAG itself introduces two bits of complexity. You can retrieve the wrong content and give that to your model. So in actual fact, your model may not be able to answer the question or task at hand at all. We can also just retrieve so much irrelevant context that our models end up hallucinating. So it's not a race to start using RAG because it can add some additional technical complexity to your stack. For other use cases where we need to kind of get that consistent structure or style or format of output, we can turn to a technique called fine-tuning. And there are typically two reasons why we need fine-tuning. The first is to improve our model's accuracy on a specific task, and the second is to improve the model's efficiency, so we can use faster, cheaper, smaller models. So a common technique from this stage will be you'll do prompt engineering with a large language model, and then with fine-tuning you may be able to get the same level of performance out of a small language model, which is faster and cheaper for your use case. So let's look at a typical journey for optimizing a model. We'll plot it on a grid of correctness and behavior. So we begin with a prompt, and then we evaluate its performance. Has it given us what we need? We might then add a few examples to those prompts, which should increase the consistency of our results. We might then want to add a retrieval step so that the examples that we've given can be brought in dynamically based on the question or the task at hand. And this can boost our model performance a little further by only injecting the relevant context for the task into the model's input. We might then prepare a data set of 50 examples or so, and we might then fine-tune the model a bit to increase our consistency. We might then tune the retrieval itself using techniques like hide, which is instead of searching for similar questions in our database, we use our model to come up with potential answers, and then we search our data sets for similar potential answers. And we can add fact-checking steps to help reduce the chance of hallucinations as well. And then finally, we can retrain our fine-tuned model on the new enhanced responses from our data retrieval steps. If premature optimization is the root of all evil, then we need to know when to stop optimizing these models as well. So how can we decide when enough optimization is good enough for the accuracy that we need? This is just a hypothetical customer services use case, and maybe it will give you some ideas for coming up with your own success metrics for a model. So firstly, we can identify success and failure cases, and we can assign estimated costs to those cases. And this lets us reason about the potential costs and the savings based on our model's performance. So let's say that solving the support case with AI may save us $20. If our AI incorrectly escalates that to a human, that may cost us $40. And if our AI is so bad and a customer churns, that might cost us $1,000. And you can see over 1,000 kind of cases, this gives us a break-even accuracy of about 81%. we can look at other metrics too to try and understand the impact of our AI solution, such as comparing CSAT scores between the human and the AI. We can retrospectively review decision accuracy of the AI's conversations, and then we can look at time to resolution as well. There are other things we can do as engineers to kind of compensate for not needing to optimize further as well. A lot of those solutions end up being kind of through UX decisions. So to minimize the impact of incorrect escalations, to avoid that additional optimization, we could get the model to prompt for more information if it's unsure. We could give our humans the ability to pass conversations back to the AI, which reduces that incorrect escalation cost. And if the intent of the conversation is unclear, our model can always hand off to a human quicker to try and avoid those particularly expensive churn events. We've talked so far about how we can categorize AI solutions with the concepts of context and consideration, and some of the common engineering techniques you might need to employ for your models to be a success. Now we'll take a look at uncovering those opportunities to apply AI within our own domains. At GearSet, one of our core values is to focus on the job to be done. A psychologist... come find me afterwards and come grab a Lego set. Thank you. Good, I counted correctly. A psychologist called Albert Bandura described humans as, I really like this description, proactive, aspiring organisms. And the job to be done framework carries this idea across into commercial markets. And it makes the claim that we buy and use things to improve ourselves, to make progress with our own jobs. And when we observe customers making compensatory behaviors, that's a signal to us that we can lean into the market demand to try and uncover a new job to be done. And that drives our product market fit. And this is the exact mindset that we need to stick to with AI, where it's so tempting to chase a shiny object, as I confessed that we did initially, instead of evaluating whether AI is the best solution to get the customer job done. We have to be mindful with AI that there may be more anxieties and inertia that get in the way compared to traditional solutions. So here you can see this diagram kind of describes the push and pull factors that you see within jobs to be done. And you can, this diagram is from a book called When Coffee and Kale Compete, which is my favorite book on job to be done. And it shows you that when customers imagine a better life situation, we need to be ready to interact with that demand and uncover their vision of the future. If we get caught up in the excitement of AI's potential without considering if it actually solves a user problem, then we're just using technology for technology's sake. And the job to be done framework helps us avoid this trap by prioritizing user needs over technology. If AI is potentially the how, then jobs to be done can give us the why. Asking why on the left helps us uncover user aspirations. We first identify the jobs by asking why, and then we explore potential solutions by asking how. The why allows us to identify if an AI capability could fulfill the user's job. In contrast, asking how uncovers the tasks where we can use AI to fulfill a user's purpose. And we should only choose AI if its capabilities can help with the user's job more effectively than other existing solutions. So it's fine to talk about all this theory, but what can we take away from this when we think about that 0 to 1 product development process of AI? Well, I think it's pretty similar to the product development processes that we already know, but we need to spend some time mapping user needs onto AI capabilities to see whether it's the right solution. Start, as you always would, by understanding your users' needs and their purpose. Jobs to be done and books like the MUM test are a great resource for discovering and validating your hypotheses. Then map the capabilities of generative AI onto possible solutions you've identified that will meet that market demand. User story maps are a really great way of doing this, and in particular I'm thinking the yellow task cards that you use in user story maps. Once you've mapped the capabilities onto possible solutions, you'll probably want to rank their desirability and their feasibility. Ulnwick's book on outcome-driven innovation is a really great tool for this, and so are decision matrices. And lastly, when you commit to a solution, prototype early, iterate often, and find customers who are happy to experiment in open collaboration with you. That's even more important with AI compared to other potential solutions. So we've explored ways of making sure we're delivering value to our customers using AI, but what are some of the popular capabilities that we're seeing shipped to production environments that appear to be hitting the spot with customers? These are 4 common capabilities that are used to help customers make progress with their jobs. So first up, we've got automation, where we can use AI to identify repetitive tasks that slow down a job's progress. If we automate these, we can free up the user's time and cognitive load. Proactivity. Predict users' needs and offer helpful suggestions or actions to speed up a job's progress. Personalization. Deliver customized user experiences to assist with their job based on their preferences and behaviors. And last but not least, analytics, where we process large data sets to uncover insights about potential user jobs. And it's interesting that underneath these 4 common capabilities, and there are a few more as well, things like accessibility, we kind of have these 3 common delivery mechanisms that we're seeing with AI. The first is where we replace the human. The AI just does the work for us autonomously. The second is where we augment human capability, where we thoughtfully drop AI into our existing workflows to assist with key tasks. And then the third one is a sidecar pattern, where AI is deployed as its own tool, ready to assist us when we need, much like a co-pilot. So I'd like to wrap up with some examples of these capabilities that we can see out in the market today. The first, with automation, is something like dbt Copilot, which is designed to help developers generate documentation, tests, and semantic models in dbt Cloud, which is a data transformation platform. Under proactivity, Salesforce Einstein Discovery can be used to find important patterns and predict churn events. Under personalization, Duolingo's AI is a language learning platform creating personalized learning experiences. And then under analytics, we've got Amazon Guard Duty, which is a threat detection service, and that continually monitors your AWS and accounts and workloads for malicious activity. So, we've explored ways of describing AI solutions using consideration and context. We've looked at some of the common engineering techniques you might need to deliver generative AI in your product. We've emphasized that AI alone won't differentiate your product, but the way you incorporate it into a user's job, that will. And lastly, we've looked at some of the common capabilities that are used to meet that user demand. If I can leave you all with a short summary of things that we've learned this year, it would be this. Start small. Don't rush to solve high context, high consideration problems. Learn to walk before you can run. Data is king. Without good training data, our models will never achieve the performance we need to solve a user's job. Defer RAG and fine-tuning. So prompt engineering is a really important first step, and it can take you a long way to success. Don't rush to use these tools because they bring their own challenges and may slow you down. Align the how with the why. Don't ship technology for technology's sake. Focus on the user demand and only choose AI if it's the best solution available. And then lastly, experiment early, often, and openly with your customers. Hearing their feedback is even more important when you're starting out on your AI journey. Thank you very much for coming to my talk.
Thank you very much, Dave. Can I just say, isn't that a fantastic explanation of product came through, as well as engineering? Really love that. Technically, you are almost hitting time, but because we're going into lunch, I feel like we could have a cheeky question or two if you want.
Yeah, I'm more than happy to answer questions now, or if people want to filter out, I can just answer them down here.
Do we have any questions here in the room?
Yes, one question.
I think everyone's just blown away by the amount of information that you've
I enjoy an
got
awkward
across.
silence.
Of course, you're at the back. No, I just wanted to make him run. I don't even have a question. No, I'm joking. Is there a visibility difference or a difference you've seen between the user acceptance of good enough for a human experienced interaction and an AI experienced interaction? So if a person will accept, say, 85% quality with the human element, say customer support, do you think that's higher or lower for AI driven?
I think it depends on how you expose that to the customer. So I think if you go to your customer and you say, this is an AI, I think particularly with customers and the kind of the market perception of AI at the minute, that bar for quality will be higher. People will expect more, they will demand more, but the actual outcome may not meet their needs. If you manage to thoughtfully kind of introduce AI into your existing workloads, rather than replacing humans and kind of, I guess, increasing that user's frustration about a solution, then I don't think you see any kind of meaningful difference. I think it largely depends on how you pitch it within your product, and quite often how you set your AI features up in terms of your customers' expectations. Does it solve all of their problems, or are you managing their expectations by scoping it to a particular task at hand? And I think that messaging is very important with AI. Great, thank you very much, everybody. Have a nice lunch.
Thank you very much. Can I just say, Dave actually flew over here to give this talk, so yeah, thank you very much.